Alrighty, let's get this party started with a description of what data structures are and how we can use our first lists. So one of the assumptions we've made throughout Code in Place so far is that every variable contains exactly one value. We've talked a lot about how variables are kind of like suitcases with a luggage tag. And in this particular case, what we're doing is we're making a suitcase that has the value 42 inside it and has the luggage tag mynum attached to it. I think in general, this is a reasonable assumption to start to make about variables because it's how we reason about our programs in our head. We have one number or one piece of text or one boolean. But as we saw back when we were writing the add two numbers, add three numbers, add four numbers functions, there is a limitation there. And that limitation is that you need to have as many variables as you have values. So if I wanted two numbers in my Python program, I'd need to create two variables. And where this really becomes a problem is if I don't know how many numbers I'm going to have in my program, I don't know how many variables I need to create. So what we're going to be talking about today is a kind of variable called a data structure, which allows us to store a lot of different values in one variable. Now, there's a rich and deep art to data structures, both in terms of how to choose which ones to use, as well as how to use them effectively. And this week, we're going to be focusing on those sorts of questions. I'm going to be telling you about lists, our first type of data structure today, and then in our next lesson, Juliet, our wonderful colleague and head Code in Place instructor, is also going to be teaching us about another data structure called dictionaries. So let's not dilly-dally anymore. Let's talk about lists. On this slide, I'm creating three lists, and I'd like to go through these in great depth. We'll start with this one over here, list of nums. Now you'll notice that this line looks a lot like any variables you've defined before. We have the name of the variable on the left over here, then an equal sign, and then something on the right side. The only thing that's really different, and believe me, I know it's very different, is what exactly is on the right side over here. Rather than just having one number, 42, like we did on this slide over here, instead we have four numbers. We've got 42, 37, 28, and 2. And what exactly does this mean? Well, it means that we're not creating a variable that has one value, we're creating a variable that has multiple values inside it, 42, 37, 28, and 2. Specifically, what I've done is I've surrounded those values with square braces and I've separated them with commas. And that is how you define a list. Just to repeat it, we've got a braces around the list and commas between the things inside the list, which we refer to generally as elements. So over here, I've made a list variable that contains four numbers. Over here, I've created another list variable called names that contains three strings or pieces of text, Brum, Waymond, and Gwen. I've also created an empty list down here, which is a list that doesn't have anything inside it yet. And so we just have a square brace to open and a square brace to close, but no commas inside because there's nothing to separate inside the list. So that's how we create a list variable. And that in and of itself is incredibly exciting because what it means is we've now got one variable that has multiple values inside it. That's a really huge step forward in our understanding of what variables are capable of. But as always, it doesn't end there. This variable is only helpful if we can actually do things with it. And to do things with it, we need to understand how lists look under the hood. Under the hood, every element in a list is assigned a position. The elements occur in a particular order in the list. So we can say, for example, that Brum is the first element of the list. Waymond is the second element, and Gwen is the third element of the list. So in programming, we actually start counting from 0 most of the time, not 1, which is a little surprising because as humans, we just count the elements on this list as 1, 2, and 3. But in programming, we count it with 0, 1, and 2. Formally, we refer to these positions as the index of a particular element on the list, and the plural of that is indices. So the indices of a list count the elements and the positions of those elements in a list and they start at 0 over here. So we can say that Brum is the element at index 0 of this list, Waymond the element at index 1, and Gwen the the element at index 2. So why is that helpful? It's helpful because it allows us to take this list over here and work on individual elements in that list. For example, I can say if I want the first element in this list, I can go ahead and say create a variable first element that's equal to names at 0. Now, once again, you'll notice that I've got square braces after the name of the list over here. And what that's saying is I would like an individual element of this list. In this case, the element at index 0, which is equal to Brum. I could also say, rather than giving me the index at element 0, give me the element at index 2, which in this case would be the third element in the list because we start counting from 0, but would be equal to Gwen because that's at position 2 in this list over here. There's one other kind of fun thing you can do with indices, and that is rather than provide 0, 1, or 2, we can actually say -1, which basically is the last element of the list instead. The takeaway here is that if we provide a negative index in a list, we count backwards from it. So because we've said -1 over here, we'd start from here and go -1 to get to the Gwen element again. That means that Waymond is also the element at index -2 and Brum the element at index -3. Alrighty, so now we have a sense of how we can pull elements out of a list. We can create a new variable and set it equal to the name of the list followed by the index inside square brackets over here. But there's actually one other fundamental operation we can do with lists, and that is updating elements in a list. If, for example, I wanted to say, all right, go ahead and change the element at index 1 over here from Waymond to Rebecca, the way I would do that is on the left side now, I would refer to an element in the list. I would say, okay, names at the index 1 is now going to be changed to be the value Rebecca. And once again, you'll see that something really powerful is happening here. We're changing part of this list without changing the entire thing. So while we've set the element at index 1 to be Rebecca, the elements at index 0 and at index 2 are all exactly the same, which is really nice because it means that we're now able to modify just one part of the list. Alright, so now that that's out of the way, let's sort of talk about one last thing that I think is really crucial, and that is how to count how many things there are in a list in Python. Well, it turns out there's a function called len whose only job is to take in a list and tell us how many elements there are in the list. Now there's an interesting detail over here, and that is that while indices start at 0, so Brum is the 0th element of this list, Rebecca is the first element of this list, and Gwen is the second element of this list, the len function does not start at 0. It starts at 1, and so it just counts the number of elements in a list like you or I would. It says, okay, there are 1, 2, 3 elements in this list, and so I'm going to give you back the number 3. Okay, so now that we have all of these different things, the ability to pull an element out of a list, put an element back into a list, and to count how many elements there are, there's a very quick program I think we can write to sort of understand exactly how these sorts of things can fit together. So let's talk about what the problem is. Essentially, we want to go from this list over here, 1, 2, 3, 4, to this list over here, 2, 4, 6, 8. And by this, I mean, I want to take each of the elements in this list and I want to multiply it by 2 to get to the new list. So 1 multiplied by 2 is 2, 2 multiplied by 2 is 4, all the way to 4 multiplied by 2 being equal to 8. Okay, so I'd encourage you now to pause this video and think a little bit about maybe how we could use some of the tools that we've already learned about to do this. But I'm going to take you through the solution. So let's go ahead and do that. So here's the code over here. I'd like to talk step by step about what's going on because while it's short, it's fairly dense code. So we're creating that list that we want to modify up here. We're saying, okay, create a new variable called numbers and set it equal to 1, 2, 3, 4. That's a list with 4 elements inside it. And now you'll notice that what I'm doing is I am using a for loop over here. And this is perhaps a more complex for loop than we've seen in other uses. So let's talk through exactly how this for loop works. Let's start by looking at range len numbers. Like we just saw, the len function counts how many elements there are in a list. So len numbers would count 1, 2, 3, 4, and so we would get the same thing as range 4 over here because we can replace len numbers with 4. So this entire for loop is therefore the same thing as saying for I in range 4. Once we have that, we know that the range function is going to give us back the numbers 0, 1, 2, and 3 individually. Now, what exactly does that mean? It means that each time the for loop goes again and again, I over here is going to be a new variable. It's going to start off equal to 0, and then it'll be equal to 1, and then equal to 2, and then equal to 3. Okay, so now we have a for loop, which is going to give us a variable that the first time is equal to 0, the second time is equal to 1, the third time is equal to 2, and the fourth time is equal to 3. So why are those numbers special? Well, they're special because they're exactly the same as the indices of this list over here. This element is the element at index 0. This element is the element at index 1. This element, the element at index 2. And this element, the element at index 3. So what does that mean? It means that this for loop over here is going to give us exactly the same numbers as we need to be indices in this list over here. So to put that quickly, this for loop loops through each of the indices in this list over here. And once it loops through each of these indices, we can use those indices to first get the element at this index over here. So if, for example, I would be equal to 0, we'd say, okay, go ahead and set I to 0 and grab the first element of this list over here. So we would grab numbers at 0. And then what we do is we would multiply whatever that number was by 2 and put it back in the list over here. So we take this 1, multiply it by 2 to get 2, and then put a 2 back over here. We then move to the next iteration of the for loop where I would be equal to 1. And at that point, we would grab the 2 from this list, multiply it by 2 to get 4, and put it back at the list. Once we've done that, we can go through the rest of the list and finally print our numbers list, and we would see 2, 4, 6, 8. So, like I said, this is a really dense program. There's a lot going on in just 5 lines of code. One of the worked examples for this lesson is this function over here. I'd really encourage you to go ahead and run that code and make sure you understand it before moving on with the rest of this lesson. If you understand this, you have a really good sense of exactly how elements can be pulled from a particular index and put back into that index. Once you're done with that, we'll move on to the next section of our lesson, operations on lists.